Hi friends, welcome to Veteach. In this section, you are able to understand the basic of the materials and as well as the semiconductor structure. So as the materials in EDC were classified as the three groups: insulators, conductors and semiconductors. So first I would like to start with the conductors. Conductor means the name itself, it is telling that it is conducting. Conducting means it is allowing the electrons from the one side to another side. For example, if you have taken the material have to be allow the electrons from the one side to another side. Then that we can say that the material is a conducting material. But how it is possible? Because the valency band and conduction band of the particular material is overlapped. So actually the valency band have to be allow the electrons to move towards to the conduction band. So in conductor, the valency band and conduction band both are overlapped. Due to that, the electrons in the valency band will be moved towards to the conduction band easily in the conductors. So for example, if you are taking the conductor, if you are connected to the one battery as a positive and negative, so this is the positive and negative, then the electricity will be passed through that conductor. The reason is that valency band electrons will easily pass to the conduction band. Easily it will be passed from the valency band to conduction band. So that's the reason. So we are saying that it is a conductors. So the conductor will be allow the electricity whenever you are giving the greater than the zero voltage, at that time also it will be allow. So next, if you are going for the insulators. So next step I am taking, that is for the insulators. So insulators means which is not allowing the electricity to that particular material. So if I am, for example, if I am taking the insulating material, this is the insulating material. If I am connecting the insulating material to the battery electricity, I want to pass through the electricity through the insulating material, then no current will be passed through the insulating material. The reason is that the conduction band valence band energy gap, the gap between the valence band and the conduction band for the insulator, it is a large gap is there. Even if I am giving the more voltage also, the gap we can't fulfill. So that's why no electron will be moved from the valency band to conduction band. You can see in the diagram itself, all the electrons are present in the valency band only. No electron is present in the conduction band. If any metal want to be a conductor, or any metal, if it is if it is allowing the electricity to that, the meaning of that one is that the conduction band should have some electrons. If I am coming for the conductor, you can see the differences between the insulator and conductor in the diagram itself. The valency band and conduction band, you can see more number of the electrons are present in the conduction band. So that's why the conduction is easily possible in the conductor materials. Okay, now coming for the insulators, the gap between the valency band and conduction band is large. So due to that, if I am giving the some voltage to that one also, it will not be pass the electrons from the valency band to conduction band. So that's why this material will not allow the any current through that one. The interesting one is the semiconductor material. Semiconductor material, the name itself it is telling it is a partially conducting. The interesting in the semiconductor material is that as a basic, initially every semiconductor material acting as an insulator. That means it will not allow the any electronics from the valency band to conduction band. So but if you are giving the some external voltage or some external energy, it may be the optical energy, it may be the thermal energy, then the electron will able to pass from the valency band to conduction band. Already I said that whenever the conduction band is having the electrons, then definitely we can say that that material is acting as a conductor. It is allowing the electricity through it. So initially all the semiconductor materials are acting as a insulators. So if I am giving the energy based on the energy gap, to fulfill that energy gap we need to give the some external energy. So if I am giving that particular energy to that one, then the valency band electron will be moved towards to the conduction band. For example, if I am taking the silicon or it may be the germanium, these both are the semiconductor material only. Silicon material and as well as the germanium material is having the some ohm energy gap, that is denoted by the EG, energy gap. The energy gaps for the all the semiconductor material is not the same, it will be different. So take the silicon, the energy gap of the silicon, it is a 0.7 EV we can call. What is the meaning of the 0.7 eV means? It is a 0.7 electron volt. If I am giving that much of the energy as the external energy to that one, then the electron will be passed from the valency band to conduction band. The structure of the semiconductor is there, and as well as how we are going to use for the designing of the transistors, diodes, and as well as the ICs. Now we are going to see that one. You can see here semiconductor structure. Here basically as an intrinsic semiconductor, actually semiconductors they are divided as a semiconductors. They are divided as a basically two types. One is the intrinsics and another one is the extrinsic. Again in the extrinsic we have two types, that is a N type and another one is P type semiconducting materials. So now as a semiconductor material basic thing we are taking, it is a intrinsic semiconductor material. Intrinsic semiconductor means here the pure semiconductor we can call, which is having the 4 valency electrons. In intrinsic semiconductor material means from the periodic table we are taking the 4 valency electrons table, that is germanium and silicon. The atomic number of the silicon it is a 14. For the silicon it is a 14. For the germanium it is a 32. So this is the crystal structure of the semiconductor. In the crystal structure of the semiconductor, the nucleus it is having the positive energy. It is having the positive energy. All the electrons based on the number, okay, based on the atomic number. The atomic number we can call it is a electrons which is present in the orbit, outer orbit from the nucleus. So the electrons, how many electrons present in the first orbit means the formula behind on that one is 2n square. If it is the first orbit, we can call it is a 2 into 1. The 1 indicates it is the first orbit. So finally the answer here it is a 2. The meaning of that one, the first orbit which is very near to nucleus, that I am saying it is a first orbit. In this orbit you can get 2 electrons. 2 electrons you can take here. So in the next orbit, how many electrons it is going to be present means second orbit which is 2 into 2 square, that equal to 2 into 4, that is 8. 2 electrons are present in the first orbit. In the second orbit 3, 4, 5, 6, 7, 8 electrons are present. On the third orbit 4 electrons are present. And the fourth orbit, like that the orbits will be there. The outermost orbit, how many electrons are present, that electrons we are calling it is a valency electrons. That electron we are calling it is a valency electron. In this crystal structure, the outermost orbit is having the 4 valency electron. So we will choose such a type of the structure, that means 4 valency electron structures we will choose as a pure semiconductor, that we can call it is a intrinsic semiconductor material. So that again I am going to take the silicon, it is a 14 and germanium it is a 32. That is the atomic number, that is telling that it is a electrons. So for example, if you are coming for here, the nucleus is there. For the nucleus very near what the orbit it is having, it is the 2, and next it is having the 8, next it is having the 4 valency electrons. The outermost orbit electrons we are calling it is a valency electrons. So valency electrons means it will be in the orbit only, but it doesn't have the sufficient energy to move from the one place to another place. So you can see the structure of this silicon, and as well as if it is the germanium also, the structure will be like this only. So if I am taking the silicon material, one thing, if I am taking here 4 valency electrons it is present, 4 valency electrons it is present, but in the crystal structure number of the silicons will be present. So that's why this is, you can take this is a silicon 1, silicon 2, like that. So each silicon atom is having the 4 valency electron. So another silicon atom also having the 4 valency electron. Like this it will be make one bond, that bond is called as a covalent bond. In the covalent bond, the electrons need a energy to break from the covalent bond. Initially it will be like this only. At normal temperature the covalent bond will not be the break. Okay, because that's the reason we are saying that basically every semiconductor material is acting as insulator, which is not allowing the electrons from the valency band to conduction band. Still the electrons is present in the valency band only. 0 degrees Kelvin semiconductor material is acting as a pure insulator, which is not allowing the electrons from the one place to other place. So you can see here in the structure also again, if we have given the some external energy to that electron, the electron will get energized. From that electron will be go out. Then the valency electron will become the free electron. So free electron means whenever the valency electron is occupied some energy from the external side, then it will become the free electron. Free electron always will be attracted by the some positive energy. So it will go to the next stage of the energy, that is a conduction band, because valency band is having the low energy level and conduction band is having the higher energy level. Whenever the valence electron is occupied the some external energy, then it will be moved from the valency band to conduction band. You can see semiconductor conductivity at 0 degrees Kelvin. So already we discussed that the silicon is having the outermost orbit is having the 4 valency electrons. That valency electron is covalent bonding with the another silicon atom. You can see here that is a covalent bonds. See, this is also covalent bond. At 0 degrees Kelvin, no valency electron is becoming the free electron. You can see here it is a pure type of the semiconductor material. Meaning of that one, it is a silicon or germanium. In both it will happen like this only. Now the semiconductor, the conductivity at 300 degrees Kelvin, we can call it is a at room temperature. How the semiconductor behavior will be there? See, room temperature 300 degrees Kelvin, the bond is going to be break, and as well as the electron which is present in the bond, from that it is coming out. So then the electron which is present here is becoming as a free electron. The valency electron now it is becoming as a free electron. So the free electron whenever it is there, then the next level, because from the valency band, electron which is present in the valency band, that we are saying it is a valency electron. From the valency band to move towards to the conduction band, we need some external energy. Once the electron is occupied that energy, then it will try to move towards to the conduction band. Why the valency electron is moving after becoming the free electron, why it is moving towards to the conduction band? Because initially the conduction band is not having the any electrons. The absent of the electrons, we can say that it is having some positive energy, then it will be try to attract, the conduction band will try to attract the valency band electron, so which is called as a free electron. So now here free electron has become like that the free electrons are going to be increases if you are increasing the temperature. Once the free electrons are increases, then the number of the electrons from the valency band it will move towards to the conduction band. So for example, to break that covalent bond for the silicon and germanium, it is having the some different energy levels. So you can see the energy required to break the covalent bond is about 0.72 electric volt in where? In germanium. That in that it is 0.1 electric volt in silicon at room temperature. So when one covalent bond breaks, the either of electron that previously involved in the bond formation comes out with keeping a vacant place behind it on the bond. So this vacancy is referred as a hole. Once the electron which is moving from here to here, then we can say that it is a hole. Here absent of electron is there, so that's why we are calling that the hole is present in the covalent bond. You can see the hole movement from the one place to other place. So here the hole is moving like this. So once the hole is moving from here to here like this, if it is moving from the one place to other place, be clear that this hole is again it is going to be fulfilled with the another electron from the covalent bond. It may be from the any other electron which is beside of this hole, that electron will become, it will be fulfill this hole, and here the hole will be create. The meaning the process of the another covalent bond electron is fulfilling the hole is called as a recombination. So due to the recombination, the holes are going to be increased, and as well as the electrons which is moving. You can see the directions of the hole is, if it is like this, the electron direction is quite opposite to this one. What is the meaning of that one? Means the hole it is going to be fulfilled by the one electron. So the electron which is coming from the covalent bond, there itself the hole will be created. So the holes are moving in the one direction, the electrons are moving it is into the opposite direction of the hole. Hole is present here, then this hole is moving towards to here. You can see in the second diagram the meaning of that one, this electron is fulfilling this hole. So that's why here you can see the hole present. You can see the hole present here. So what I want to say here, The hole, if it is moving like this, the electrons are moving, it is into the opposite direction. So at 300 degrees Kelvin, if I am giving the sufficient energy to that one, then the electron is from the covalent bond, valence electron is coming out, it is becoming the free electron, and as well as it is moving and it is filling with the another hole. Then that's process we are saying it is a recombination. Again from that the free electron is coming, again it is going to be fulfill the another hole. This entire process is called as a recombination, and as well as due to that what will happen, the valency electron it is moving towards to the conduction band. So that's why we can say that it is allowing some electricity. Initially semiconductor is working as an insulator, so at certain range it is from that range, actually if it is having the some energy gap, if you fulfill that energy gap, from that energy gap the semiconductor material will be work as a conductor. Thank you.